Hi guys, welcome back to my channel. Today we're going to be having a look at the discriminant and how we can use the discriminant to determine how many real roots there are for a solution. So it's something I want to make really clear before we jump into this. We can have an imaginary root, but in this case we're only looking at factorizing or solving quadratics over R, which means that we're only looking at solving quadratics that have a value or a solution that is a real number. So one really easy way to do that is if we have a look, so I'm just going to get my highlighter up here. If we have a look at the quadratic formula here, I can see that this value here is really going to determine whether or not I'm going to have a real or an imaginary root. Because you cannot have a real value if I have the square root of a negative number. So it's really simple then to use this discriminant without going ahead and calculating the entire solution to see before if it is actually going to be a real root or not. So a couple of little tips and tricks. So if my discriminant is greater than 0, so it's a positive value, that means I'm going to have two real solutions. And this is what we're used to dealing with here, okay? Similarly, if my determinant is equal to 0, that means that I'm going to have one real solution. And if it's a negative value, then it's going to be an imaginary solution. So therefore not a real solution. So let's see how we use this discriminant now. So for each of the following quadratics, we're going to calculate the discriminant and then we're going to state the number and type of factors. So do we notice here how it's not actually asking us to solve what the quadratic is, but rather to determine what the discriminant is? So having a look at this first example here, we have 2x squared plus 15x plus 13. So let's go ahead and let's write this using our discriminant formula. So to start with, what I've done is I've written out my key pieces of information. So I've got my value for A, B, and C, which are 2, 15, and 13 respectively. So my formula that I'm going to use, this is going to be the value that's found under that square root sign, which is the b squared minus 4ac. So as a reminder, if we have a positive value under the root sign, that means there's going to be two distinct roots that are real. If we have a 0 underneath the root sign, then it's going to be one unique real solution. And if it is a negative value, then that means we're not going to have any real solutions, although we may potentially have imaginary solutions. So let's have a go. Let's substitute some of these values in now. So in this case, our b squared is going to be 15 squared minus 4 times 2 times by 13. So 15 squared is going to give me 225. I can double 13 here is 26, double that again would be 52, double that again would be 104. So 225 minus 104, and that is going to give us our answer. So that is going to give us 101. Oh, no, sorry, 121. Okay, so straight away I can see that this is going to have a real solution. So if I was going to pop this underneath my square root sign here, the square root of 121 is going to be equal to positive or negative 11. So whatever these values end up being, I'm going to add 11 to get my first root, and then I'm going to subtract 11 to get my second root. But the question hasn't actually asked us to find the roots. All they've asked us to do is asked us to find the value of the discriminant and also to determine the number of roots. So first of all, I can say that the value of the discriminant is 121, and there are going to be two roots because this value of 121 is greater than 0. Okay, so let's move a little bit quicker through this next example now. Here I have my second equation, 5x squared minus 6x plus 9. And we can see that the values for A, B, and C are going to be 5, negative 6, and 9 respectively. So I've got my formula, and just as a reminder, this is the formula that comes from underneath the root sign in the quadratic equation. So let's go ahead now and let's substitute in the values that we know. So this first one, B, is going to be negative 6 squared minus 4 times 5 times 9. Okay, so simplifying that now, we're going to have 36 take away 4 times 5 is 20, 20 times 9 is 180. So we can see that this is probably going to be a negative value here. All right, so 36 take away 180 is going to be negative 144. So the value of my discriminant, so we're going to use this triangle, is going to be equal to negative 144. And as this is, whoops, sorry, that should be a triangle. As my triangle, my discriminant is less than 0. There are no real solutions. If you're familiar with complex numbers, then you can probably tell that if I was going to find these roots, then this would actually be equal to positive, the square root of negative 144 is going to be equal to positive or negative 12i. All right, let's go through another couple of examples now. Here we have our third example, negative 3x squared plus 3x plus 8. And my values of a, b, and c are going to be negative 3, 3, and 8, respectively. So substituting those values in, we're going to have 3 squared minus 4 times negative 3 times by positive 8. Simplifying here, we have 9 times, take away 4 times negative 3 times 8. Well, 4 times 3 is going to be 12. 12 times 8 is going to be 96. And we are going to add those two values since we have our negative and our negative here. Okay, so straight away we can see that this is going to be a positive solution. So that's going to give me a value of 105. So again, because our discriminant is equal to 105, that means that our discriminant is greater than 0. So therefore, we have two real roots. All right, last one now. So starting off with our equation, we have 81 over 4x squared minus 12x plus 16 over 9. So my values for a, b, and c respectively are 81 over 4, negative 12, and 16 over 9. So again, I have my formula, remembering that comes from underneath the root sign from the quadratic equation. So here my value of b is negative 12, so we have negative 12 squared minus 4 times by 81 over 4, which simplifies immediately, times by 16 over 9. And we could probably simplify this a little bit easily as well, because if we have 81 over 9, 81 over 9 is going to simplify to 9. So this is going to be the same as 144 minus 9 times by 16. Now, 9 times by 6 is 54. 9 times by 10 is 90. So in total, we're going to have 144 on this side here. So 144, take away 144, is going to be 0. So our discriminant has a value of 0. So remember, when our discriminant is positive, we have two roots. When it's negative, we have no roots. And when it's equal to 0, that means that we only have one real solution. So if I was going to draw this graphically, I'm not exactly sure what this specific function would look like, so I could be wrong here when I draw this. But when this comes through, it's just going to touch the axis at this point here. So it only has one real solution. All right, guys, so that's how we use the discriminant to determine if there are going to be real roots for a quadratic equation, and also to see how many roots there are going to be. All right, guys, I'll leave it there, and I'll see you in the next one.